Okay, so if we have a polynomial, we know ways to find linear factors, at least linear factors with rational coefficients. How would we find irreducible quadratic factors? Well, one way is we factor out linear factors until all that's left is a quadratic, and then we discover that that quadratic is irreducible. The other way to find irreducible quadratic factors is that we might guess them. Or in the context of a math class, we might be given an irreducible quadratic factor. In real life, typically we'll guess an irreducible quadratic factor in some way based on how we built the polynomial in the first place, right? High degree polynomials don't just fall out of the sky, they come from somewhere. And often the place the polynomial came from suggests an irreducible quadratic factor it might have. So if we're in possession of an irreducible quadratic factor, how do we use that to figure out the remaining factors? Well, we divide it out and see what's left. So suppose we have the polynomial x to the fourth minus 4x to the third plus 3x squared plus 2x minus 6, and it has x squared minus 2x plus 2 as an irreducible quadratic factor. You can check the discriminant and confirm for yourself that that quadratic is indeed irreducible. We're going to use that to fully factor the polynomial. To do that, first we'll divide by that x squared minus 2x plus 2. Now, unfortunately, this is not a linear factor, so we cannot use synthetic division. We need to write out the whole polynomial long division. We're going to take x squared minus 2x plus 2 into x to the fourth minus 4x to the third plus 3x squared plus 2x minus 6. I'm spacing out my terms to give myself room to write. And then term by term, we'll say x squared goes into x to the fourth. Well, x squared times another x squared is x to the fourth. So x squared times my divisor, I'll have x to the fourth minus 2x to the third plus 2x squared. And then I'll subtract negative x to the third minus negative 2x to the third. So I'm taking negative 4 minus negative 2. I'm left with negative 2x to the third. 3x squared minus 2x squared is just a 1x squared. And then I'll bring down my plus 2x. Next, x squared goes into negative 2x to the third. That's going to be a negative 2x. So multiplying by my divisor, negative 2x times x squared. That's going to be negative 2x to the third. Negative 2x times another negative 2x. That's going to be plus 4x squared. And then negative 2x times positive 2. That's going to be minus 4x. And now I'm subtracting again. So negative 2x to the third minus 2x to the third is 0. X squared minus 4x squared, I'm saying 1 minus 4 is negative 3. I'll have negative 3x squared. And then 2 minus negative 4 is positive 6. So I'll have plus 6x. Finally, I'll bring down that last -6. And it's time for my last round of division. So x squared again goes into -3x squared. That's going to be a -3. So -3 times x squared is -3x squared, just like I hoped. -3 times a -2x is going to be a +6x. -3 times a +2 is going to be a -6. And my remainder is 0. If I don't get a remainder of 0, something is wrong. Either that wasn't a factor, or I made a mistake in my division. But at this point, this must be 0, or something has gone wrong. As it is, we're good. We've gotten the remaining polynomial factor, x squared minus 2x minus 3. And the good news is, x squared minus 2x minus 3 is something that we can factor using our basic techniques. So we have a quadratic leading coefficient 1. The numbers that appear in the AC method are going to be the same numbers that appear in our factors. We want two numbers that multiply to -3 and add up to -2. To get -3, I need a negative and a positive. It can only be a 1 and a 3. So I need to have -3 times +1. So my remaining polynomial factor was very easy to factor after I divided out that irreducible quadratic. I'm left with the factors, the initial irreducible quadratic I was given, x squared minus 2x plus 2, times the x minus 3, x plus 1 that I just found. So dividing out that irreducible quadratic gave me something much lower degree that I could then continue factoring using the techniques I already have.